Hey, all my tubers out there. That's a joke about roots and a joke about YouTube. Hopefully this is working okay. Who knows? Anyways, I'm going to talk to you about roots. This is a short one, but stay tuned to the end. Don't forget, there's a secret. Okay. You know what? I'm going to treat myself. A little chewing gum. That's what I'm talking about. You ready to talk roots? Okay. Well, we got a couple major flavors of roots, and so number 18 will compare a few different parts of the table. So the first thing we're talking about are tap roots, which are mostly in dicots, and then we also have some fibrous roots, which we find in monocots. Now I recognize it only gets us partway through that table. Stay tuned for the next slide. Okay. Okay, so the classic example of a taproot is a carrot. So I want you to picture a carrot, and I'm not talking about Mr. Carroty. That is how he signs his name, with a caret and then a hyphen and then a letter T, capitalized, of course. That's not what I'm talking about. I'm talking about a carrot. And this is the classic example of a taproot. This is long, a single, solid, solitary root. So this is the first row of your table for number 18. So that's pretty clear. I don't think that's that difficult to understand. That obviously means the next part of your table is going to be, well, it's about fibrous roots. So coming up, hold on, here we go. Fibrous roots, so the last row of your table. So there are these shallow roots. You see the grass there in the picture. That's a pretty standard picture of fibrous roots. So grasses, if you ever plucked up a chunk of crabgrass from your lawn, even though they're not real deep, they're pretty shallow normally, they are numerous. So our tap roots is a single root, found mostly, again, like I mentioned before, in dicots, but these fibrous roots, they're found mostly in monocots. They're shallow, they're numerous. Grass, corn, those are the best examples of fibrous roots that I know of. So I will talk about some of these parts of the roots here, but you should know that, like, all the component parts we're talking about come from different tissue systems. We talked before in the previous lesson about dermal, vascular, and ground tissue, so they all play a role in roots. It's a little bit different than the role they play in stems and leaves, but they all play important roles, and we'll discuss that. And of course, it's all devoted to getting the water and associated dissolved things into the plant so it can be transported through the, what's water transported through? Almost gave it away. Xylem. So roots absorb the water to go through the xylem. Don't forget. Root hairs? Yes, please. Let's talk about root hairs. But first, here's the plan. Number 19. We're going to label, and then we're going to answer a question or two. In this case, we'll label root hairs. We'll answer questions about them on 20. And we'll hit 19, and then we'll answer some questions. And then we'll hit 19, and then we'll answer some questions. So don't forget that we're labeling stuff on 19, our root. So that being said, root hairs. Root hairs are the structure on the root responsible for doing all that water absorption. Okay, so you've labeled that on your diagram. It's on the top right of your diagram. I know on the picture here it's on the left, but on your diagram, top right, here's something to keep in mind about root hairs. What makes them good at absorbing water? They are numerous, which is a huge increase in the surface area. So when you're answering number 20, surface area is the important thing about root hairs to understand and to remember. Surface area, root hairs. Do you comprende? The epidermis is the next thing I want to label on 19. And so that's your top left structure that's where the arrow is for your epidermis. You guys know about epidermis, dermal tissue, it's the outside layer. Well, the root hairs are made of epidermis. And of course, it's doing all the water absorption. So 21, it's busy absorbing all the water. I guess there's nothing else to say about that. As we work our way from interior to exterior on our leaf, nope, exterior to interior, we're going from out to in. We already did that, root hairs and epidermis. Right, that's of course on the outside. The next layer in is the cortex, and this is the ground tissue layer. Remember I said before it's the rice of your burrito? Well, the form the rice takes in a root, this ground tissue, is something called the cortex. So you've got that labeled. That's the third structure down on the left on your diagram. So make sure you get that cortex labeled. Okay, thank you. Okay, next we're talking endodermis. Now we've done epidermis, and you have a sense of what that means, that looks like. The endo means, of course, inside. And so we have a dermal tissue layer on the inside. That's right, dermal tissue on the inside. So why is it there? What's it doing? It's containing all the vascular tissue that's in the middle. So in your diagram, all the really pretty kind of tan and blue and purple tissue, the tubes, that's our vascular tissue, which we're going to get to in a second. Your endodermis contains it and encloses it. And this would be your second labeled structure down on the left of your diagram. Any questions? Okay, well now we're talking the vascular cylinder. So this is where our vascular tissue is in a root. It's kind of simple, it's pretty straightforward. It's the middle of our root. So again, it's contained by the endodermis, and it consists of xylem and phloem, our two vascular tissues. So don't forget this. On the far right of your diagram, you can just label that bundled up phloem and xylem as the vascular cylinder. Okay, so let's talk about the next structure to label. We're through number 24. So there's no question for this, but apical meristem, this is the stuff that I want you to label. It's the bottom right on your diagram. It's of course tissue of growth. The next structure is what protects it all. Bottom left of you, question number 25. That's the root cap, man. So if we have all this tissue of growth, the apical meristem, at the very end of a growing root, you better protect it as that root's growing down through the soil, rocky soil, sandy soil, clay soil, loam. Who knows whether the kind of debris is down there? Well, the root cap is like the little helmet on the root. That's right, protected. Excellent visual I gave you there. That will probably help you remember that for a while. Quiz time! Taproots, they're more common than fibrous roots. Where? So what kind of plant has those taproots? You don't remember? Well, you could, of course, check the table in your notes, but you shouldn't need to. Oh, that's right, you got it. Dicots. It's fibrous roots that are in monocots. Okay, so where do you find the cells that do all the dividing? So where's their growth in a root? That's right. I heard it in the back there. Next time, raise your hand. Apical meristem, tissue of growth. So proud of you. Tough layer of cells. It covers the root tip. Protects the root tip, protects the growing, developing apical meristem. Oops, gave that one away. It's not D. What is it? That's right, it's the helmet, so it's a root cap. You got it, not even challenge. Where do you find xylem and phloem, you say? Easy. They're vascular tissues, so you find them in the vascular cylinder in a root. Shh, secrets. Here's one. I'm repulsed by zucchini. I find it disgusting. I know this is a terrible thing for me to say with the whole Obetz deal, but I'm disgusted by zucchini. I'm fine with cukes. Fine with yellow squash. Anything with zucchini in it, I immediately can detect the zucchini and begin retching. I think it's because my mom used to make it as kids. She put Parmesan cheese in it. I can smell it right now. It's just filth to me. No. Zucchini, no.